So now let's see what we have in the receiver. As we said, since we are assuming the additive white Gaussian noise channel, that means the received signal will be given by the transmitted signal plus the noise samples that we generated. So now we can go and analyze this signal in different domains. I will start with the time domain and then the frequency domain, where we'll plot the spectrum. So for the time domain, just like we did before for the transmitted signal, we will plot the real and imaginary part separately. And also in this case, I will plot both the transmitted signal and the received signal, just for the sake of the comparison, so that we can see the differences between these two. And also I'll just plot the first 10 symbols so that we can easily see the pattern of the signals that we are receiving. So let me plot this one so that we can observe. This one is not good. Let me plot it again. Yeah, way better. So as we can see, the blue one here is the signal that we transmitted, which is clean, and the red one is the one that we are receiving, which we can easily see the effect of the noise on it. So as the strength of the noise increases, that means as the SNR value goes down, the effect of the noise becomes more stronger, such that at some point we will not even be able to see the shape of the rectangular shape of the symbols of the signal. So in that case, that means in the detection you will make too much errors. So now let's observe the same thing from the frequency domain. That is, we will plot the power spectrum of both. I'll do both the transmitted and the received signal for the sake of comparison. Again, we will use the P-Welch function here. So, and in the plotting also, I will normalize the power spectrums so that we can easily compare the two. So let me plot this one as well. So this is it. This is the power spectrum of the signal that we transmitted, and this is the power spectrum of the received signal. So we can easily see the difference between them. This one is of course cleaner than this one because of the noise, and also you can easily see the effect of the noise. For example, if you check here, the side lobe here is around minus 30 dB, but here is above 25. So this is because of the noise. That means here the power is increased, and that is because of the noise, the contribution of the noise power, which is more visible here than here, because here you have more, the signal is more stronger, so the effect of the signal is negligible. But in the side lobes, where the power is less, the effect of the signal is stronger. So as we increase the strength of the signal, of course, if the SNR value goes down, that means even this one can be heavily affected by the signal as well. So in the next part, we will do more analysis of the received signal in the modulation domain.